Hi everyone, this is Rahul and welcome to Learn with ER. So in this video we are going to talk about matrix, where we are going to talk about this question. So as you can see, there are three equations in front of you. The first equation is x1 plus x2 plus 2x3 equals 1. The second equation is x1 plus 2x2 plus 3x3 equals 2. And the third equation is x1 plus 4x2 plus ax3 equals 4. And it's said that this group of equation has this unique solution. Only possible value of a will be what? And your options are this 4 options. Okay, so I hope you have paused the video and you have written the entire question, because if you haven't, then I will tell you to do that. Okay, now I'm going to rub this question and start off with the solution. Okay, so I hope you have already written. So let's start with the solution. So as the question says, since these three equations are in the form of this thing, ax equals to b, you know what this thing means? It means it's a group of non-homogeneous equation, isn't it? So it's a group of non-homogeneous equation. Now, what do you mean by non-homogeneous equation? That means we are going to have an augmented form of matrix. So let us first of all find the augmented matrix for this particular question. So if you talk about the augmented matrix form, so let us first of all try to compile this. So the first one is x1 plus x2 plus 2x3 equals 1. So the first one will be 1, then x1, x2, 2x3. So coefficients are 1, 1, 2, and the last one is 1. The first one, second one is going to be 1, 2, 3, 2. 1, 2, 3, 2. We are just taking the coefficients. And third one will be 1, 4, a 4. 1, 4, a 4. And in between we'll put a gap, because that is how the augmented matrix is written. Right? So we have already got our augmented matrix form, which we are going to now convert into the echelon form, so that we are going to find the rank of the matrix. Why? Because as the question is saying that this group has a unique solution, so we will put this particular theory behind the unique solution, which says that the rank of the coefficient matrix A will be equal to rank of the augmented matrix A slash B will be equals to n, where n stands for the number of variables. And number of variables, which is n, here is 3. So which clearly states that if it is having a unique solution, this is the criteria, and the rank and the rank of the augmented matrix form both will be equal to 3. So we already know that this is having a unique solution, so we will already consider the fact that we are having a rank of 3. Now from the echelon form we will be showing them that yes, this is having a rank of 3, and somewhere down there we can be able to conclude the value of A, right? So let us first of all proceed through this particular journey. Now I will rub this particular part because I'm going to write the next portion over there. So from this part we can convert this thing here. Now we are going to introduce some operation, because we are going to change now the different elements in order to bring it to the echelon form. So the first change we are going to do is, the first one will be given as R2 minus R1, and R3 minus R1. So according to echelon form, what we need to do, we need to increase the number of zeros as we proceed through the rows, right? So the first one will be as usual, since we have made no changes in the row 1. We are starting with the change in row 2 and then followed by row 3. So the first one will be 1, 1, 2, 1 as usual. So second one, R2 minus R1, the first one will be 0 as you can see clearly, and this one will be 2 minus 1, which is 1. This one will be 3 minus 2, again this is 1. 2 minus 1 will be again 1. Third one will be 1 minus 1, again this is 0. Then 4 minus 1, which is 3. Then a minus 2, this will be a minus 2 only since we don't know what is a, and 4 minus 1, which is 3. And we are going to put this boundary. Okay, so this is the first change that we have made on this particular matrix. So if you don't know what is non-homogeneous equation, what is echelon form, how the rank is determined for a matrix, then I will urge you to go through this particular theories before you attempt this kind of question. And if you have already gone through this theory, I hope this will be quite clear to you. So the next one will be given as, now see how the second change is made. Now see, the first set of zeros have already come. Now we are going to make this one 0, and in order to make this one 0, we are going to introduce another operation. The operation will be done with R3, right? So we are going to say that R3 will be equals to R3 minus 3 into R2. Now if we pull this operation, what will happen is that the 0 and 0 will not get hampered. At the same time, here if we introduce 3 multiplied with this particular thing, and then if we subtract and find the difference, we are getting 0 for this one, which will bring 0 here, and this is how we are going to achieve the echelon form. So let us go to this particular part also. So as you can see here, the first 2 rows will be unaffected, so we are just writing them as it is, 1, 1, 2, 1. Then the second one will be 0, then 1, then 1 and 1. And the third one, now see, 0 into 3, 0 minus 3 into 0 will be 0. 3 minus 3 into 1, that is 3 minus 3 will be 0. A minus 2 minus 3 into 1, so a minus 2 minus 3, that will be a minus 5. Okay. Then 3 minus 3 into 1, again this one will be 0. Okay. So, since we have proceeded the leading number of zeros, so this is in its echelon form. So this is the echelon form of the matrix. So this is in its echelon form. I hope you can see this. This is in its echelon form. Now, from here, what we can conclude? We can conclude the fact that if the rank of this particular matrix has to be 3, then this particular row needs to be a non-zero row, because as we know, the number of non-zero rows will give us the rank of the matrix. Now, if this has to be a non-zero row, then don't you think that this a minus 5 cannot be 0? Because if a minus 5 is equals to 0, then this row becomes a 0 row, and that will say that the rank of this matrix is 2. But as we know, if it is a case of a unique solution, which I have already said here, the rank of A will be equivalent to the rank of augmented matrix, and that will be equivalent to 3, because the variable, the number of variables here is 3, the x here is 3, right? So if I talk about the rank of A here, this cannot be 0, because if this is 0, the rank of A is going to be 2. Also, if I talk about the rank of the augmented matrix here, still this cannot be 0, because if this is 0, the rank of the augmented matrix is also going to be 2. But then again, there's a problem, because the rank here should be 3, because the number of variables is 3. So we can finally conclude this fact for sure, that a minus 5 cannot be equals to 0. So what we can write from here, the straight conclusion which I can draw, that a minus 5 cannot be equal to 0. So if a minus 5 cannot be equals to 0, that means I can say that a cannot be equals to 5. So this is, I guess, the option which was in the last, the option number 4, and that is the answer to your question on this particular non-homogeneous equation. So I hope you have got this particular question very well, and we will come with some more videos where we will discuss some more questions on different chapters. So please keep watching us, please keep liking us. If you have liked this video, don't forget to hit a like and also follow our page on Facebook. Until then, this is Rahul signing off. Take care. Bye-bye.